Hello, welcome to Lesson 2, Integer Rules. Today we are going to practice adding, subtracting, multiplying, and dividing integers. Before we begin, let's look at our key vocabulary words. Integers, the set of all positive and negative numbers. Opposites, -4, +4, 2, and -2. So those are our two key vocabulary words that I want you to become familiar with. Integers and opposites. I'm going to draw a number line and I'm going to show you why numbers are considered opposites. Okay? Opposites, -2 and +2. They are both 2 units from 0. Okay? So they are opposites. One's negative, one's positive. If I would add those two numbers, I would get a 0. Same thing for -1 and +1. -1 is 1 unit from 0, +1 is 1 unit from 0, and when I add those opposites, I get 0, okay? So anytime you add opposites together, you're always going to come up with the answer of 0. All right, so let's go ahead and get started with adding integers. Let's take a look at the slide for the rule of adding integers with the same sign. Adding integers when the signs are the same, simply add the integers and keep the sign. So let's practice that skill first. Okay, so let's just pick out two positive numbers. Perhaps 1 plus 4. Okay, they're both positive. Our answer is going to be positive. 1 plus 4 is 5. Same signs, they're positive. My answer is positive. All right, how about 2 plus 7? Again, they're both positive, so my answer is going to be positive. It doesn't get any more simple than that, okay? Now, if they would be negative, okay? If we would have a -1 plus a -4, well, they're still the same sign, so their answer would now be a -5. -2 plus -7, the answer would be -9. And when you're dealing with negative numbers, I like to think about owing someone money, okay? So if I borrowed $1 and then I borrowed 4 more, now I'm in the whole $5. So when you have a negative number, you could always refer to owing someone money, okay? Now, what do we do when our signs are different? So let's take a look at the slide that tells us the rule for adding integers with different signs. Different signs. Subtract the integers and keep the sign of the bigger number, the absolute value. Okay, so let's practice a few examples when the signs are different. Okay, this time we have a -5 plus a +8. So the rule states when the signs are different, you need to subtract. So 8 minus 5 is 3. And then the last part of that rule said to keep the sign of the bigger number, the absolute value number. So the bigger number is positive, 8. The positive value, or the absolute value of 8 is 8 units. The absolute value of -5 would be 5. So we're going to keep the answer positive, okay? Let's try another example. If we would have -20 plus 12, okay? The signs are different, so we're going to subtract 20 minus 12 is 8. But this time, my answer would be -8. Why is it negative? Because the largest absolute value is 20. Okay, the absolute value of -20 is 20. And remember, absolute value is in those little bars. Okay, the absolute value of -20 is 20. The absolute value of 12 is 12. Okay, so our answer would be negative. Okay, and again, think about money. Perhaps you owe someone $20 and you pay them back 12. Well, you still owe them $8. Okay, let's try one more. How about -33 plus 17, okay? The signs are different, so we're going to have to subtract. So 33 minus 17, some old-fashioned subtraction. So we're going to have to borrow. This becomes 13, this is 2. 13 minus 7 is 6. 2 minus 1 is 1. So our answer would be 16. But would it be a positive 16 or a negative 16? So we'll look at the absolute value of both of those numbers. And since -33 has the greatest absolute value, our answer would also have to be negative. So that wasn't too bad. Let's move on to subtracting integers. Let's look at the rule for subtracting integers. Use the phrase, leave it, add it, change it. Leave the sign of the first number, change the subtraction sign to addition, change the sign of the second number. Okay, so when we are subtracting integers, we're going to use the catchphrase, leave it, add it, change it. So leave it, add it, change it. And you'll hear me say that over and over. So leave it, add it, change it. So we're going to subtract some integers, 5 minus 9. Okay, so the rule is to leave the first number alone, change the subtraction symbol to addition, and change the sign of the last number. So now 5 minus 9 is simply 5 plus negative 9. So I have to go back to the addition rule. When the signs are different, you simply subtract. And I'd keep the sign of the largest absolute value. So 5 plus negative 9 would give us negative 4. Hopefully that makes sense. We'll try several problems here. Okay. All right. So how about negative 12 minus 20? Okay. So negative 12 minus 20. Again, always go back to your catchphrase, leave it, add it, change it. So leave negative 12 alone, change your minus sign to addition, and change positive 20 to negative 20. Now I'm at the rule whenever your signs are the same. So when the signs are the same, you simply do the math, you add those numbers, 12 plus 20 is 32, and you would keep their sign. So now we have negative 32 for our answer. So hopefully you're catching on. Let's do one more. Okay. What if we had negative 14 minus negative 12? Okay. Again, we're using leave it, add it, change it every time we see a subtraction problem. So leave it, add it, change it. So now we have negative 14 plus 12. So the signs are different. I would have to subtract and keep the sign of the largest absolute value. All right, let's move on to multiplying integers. Same sign, 2 positives equal a positive. 2 negatives equal a positive. So let's practice doing some of those problems. All right, so we're going to practice multiplying integers. So if we had negative 5 times negative 6, so their signs are the same, so that's going to equal a positive. 2 negatives equal a positive. So my answer would be a positive 30. What if it was 6 times 4? Okay, the signs are the same. They're both positive. My answer would be positive. Okay, so whenever your signs are the same, when you're multiplying integers, you're going to have a positive answer. Okay, what happens if we have different signs? So let's look at the rule for different signs when multiplying integers. A negative integer multiplied by a positive integer will equal a negative integer. All right, so let's practice that skill. How about negative 7 times a positive 6? Well, 7 times 6 is simply 42, and the rule states a negative times a positive would yield a negative answer. All right, let's do another one. How about positive 12 times negative 6? Okay, positive 12 times negative 6. So I'm simply going to do the math. 12 times 6, I can come off to the side. All right, 6 times 2 is 12, carry my 1. That would equal 72. But the answer is going to be a negative 72. So, long story short, if your signs are the same and you're multiplying, you're going to have a positive answer. If your signs are different, you'll have a negative answer. So let's look at the rules for dividing integers. Dividing integer rules. The same sign. 2 positives equal a positive, 2 negatives equal a positive. So let's try that. If we're dividing a positive 49 by a positive 7, 2 positive numbers will equal a positive answer. Okay? if I had a negative 18 divided by a negative 6? Two negative integers will equal a positive integer, okay? So if your signs are the same and you're dividing, your answer will be positive every time. Let's take a look at the rule for dividing integers when the signs are different. Different signs. Division involving a positive and negative integer equals a negative integer. So let's try that. Okay, so if our signs are different, perhaps I have a negative 10 being divided by a positive 2. Well, the signs are different, so my answer will be negative. So negative 10 divided by 2 equals a negative 5. All right, how about a positive 81 being divided by a negative 9? The signs are different, so our answer would be a negative. So we've covered a lot here. What I want to do now is sort of like a mixed review, and let's familiarize with all the rules. Okay? All right, so let's practice a few different problems. If we had 3 minus negative 6, what is the rule again when you're subtracting integers? That's right, you're going to say leave it, add it, change it. Leave it, add it, change it. And now it becomes a simple addition problem. 3 plus 6 is 9. Okay? What if we had a negative 12 plus a negative 13? What was the rule when your signs are the same and you're adding? You simply do the math and keep the sign. So negative 12 plus negative 13 would be a negative 25. All right? What do we do when our signs are different and we're adding? So what if we had negative 10 plus 7? If the signs are different, what was that rule? You simply subtract the integers and keep the sign of the largest absolute value. So 10 minus 7 is 3, and you keep the sign of the largest absolute value, which is 10. Okay? 25 divided by a negative 5. The signs are different and I'm dividing. The answer is going to be negative. Okay? Let's do a multiplication. How about 14 times 2? Well, they're both positive integers, so my answer is going to be positive. 14 times 2 would simply be 28. So we covered a lot in this lesson. Feel free to go back and look at the slides at the end to familiarize yourself with the integer rules. I hope to see you in Lesson 3.